Hi, welcome back to Moose in Chemistry. This is Gas's Gay-Lussac's Law Introduction. Well, what is Gay-Lussac's Law? Well, it's a gas law that shows a relationship between pressure and temperature, where our volume remains constant. Originally, Gay-Lussac's law is written as P1 over T1 equals P2 over T2. But I've rewritten it as P1 T2 equals P2 T1. And why did I do that? Because really simply, it's easier for your brain to read it that way. Think about this. When you're solving Gay-Lussac problems, you're going to be doing different formula variants. So what are some of the formula variants? Well, if you're looking for P1, you're simply going to put T2 underneath P2 T1. Or if you're looking for T2, you're going to move P1 underneath P2 T1. Or if you're going to find P2, you're going to simply move T1 under P1 T2. And if you're finding T1, you're simply going to put P2 under P1 T2. Now, Gay-Lussac's law does have some practical uses. And what are they? Well, first of all, cooking with a pressure cooker. Think about this. You put water in a pressure cooker, you put your vegetables, your meat, whatever you're cooking in there, right? And then you clamp down the lid on the pressure cooker. And then you turn on the stove underneath. Well, the heat from the stove heats the water. And the pressure of the water vapor trying to escape starts building up inside the pressure cooker. So it creates more atmospheric pressure on top of the water, pushing the gas back down into the water. So what I'm trying to say in simple terms is you can raise the boiling point of water way beyond 100 degrees centigrade or 212 degrees Fahrenheit. So in essence, you're creating a super cooker or like a microwave of sorts because you're cooking the food faster using a pressure cooker. Because you can raise the temperature of water beyond boiling because the partial pressure above the water is high and pushes the water vapor back down into the water, cooking the food a whole lot faster. Well, aerosol spray is another practical use for Gay-Lussac's law. And firing projectiles. Think about this. A bullet in a cartridge has the gunpowder inside the cartridge, right? So when the firing pin hits the primer, it ignites the gunpowder in the cartridge. Well, that high temperature of igniting the powder causes the pressure to expand exponentially inside the cartridge. Well, the bullet then is fired loose of its cartridge, sending it straight out. So Gay-Lussac's law has a lot of practical applications. Well, listen, if you guys like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly. I will see you back here at Moose in Chemistry.